learners. Today we will discuss about the physical properties of magma, and this topic pertains to the course Petrology. The course code is BGYCT 135. This is the outline of our discussion today. Concept of magma, we will discuss about the types, followed by the physical properties, then composition and constituents of magma, chemical and mineralogical composition of magma, magmatic differentiation, origin of magma, and then we will lastly summarize. Recall that we have discussed about the classification of igneous rocks in the previous video. Now in this video you will get acquainted with the physical properties of the magma. Before we initiate with the discussion, recall two terms. Primary rocks, they are also known as igneous rocks, and they are the first rocks to form on earth. They are formed by cooling and crystallization of magma or lava. And then another term, that is secondary rocks. They are also known as sedimentary rocks, and they are formed by disintegration and deposition of the pre-existing rocks. Let us learn what do you mean by the term magma. This term magma, it is derived from the Greek word which means thick, ungent, and magma is a mixture of molten or semi-molten comprising of volatiles and solids. Magma solidifies at deeper levels inside the earth, and it is collected in a magma chamber that is found beneath the surface of the earth. When it extrudes on the surface of the earth, it is known as lava. Lava may be explosive to form pyroclastic rocks. Now here on your screens you can see the difference between magma and lava. You see, beneath the surface of the earth there is a pool, and magma is pooled beneath the surface of the earth, and whereas you see lava, it is coming and it is flowing on the surface of the earth, and this is known as lava. Another slide you see freshly erupted lava that is flowing on the surface of the earth, and here you can see the lava flows that have cooled and crystallized, and you can see ropey lava also on top left and bottom right. You know, there are about 700 types of igneous rocks that have been reported on earth. You must be thinking that so many different types of magma must be there, and they are forming or they are giving rise to different types of rocks. But let me tell you, different types of igneous rocks are formed due to differentiation of magma. And in the next video, we will discuss about the processes of differentiation of magma that are responsible for formation of different types of igneous rocks. But before that, let us know few terms like primary magma, parental magma, and primitive magma. Now what is primary magma? Primary magma or primary melt, it refers to the initial composition of the magma before it underwent any differentiation process. Primary magma, they must have more than 10% magnesium oxide by weight, and primary magma evolves into parental magma by the process of differentiation. In other words, this magma is modified by the process of differentiation. However, let me tell you, it's very rare to find primary magma in nature. Now primitive magma. Primitive magma, it's also known as primitive melt. It refers to the primary magma derived from the mantle. Now the composition of the primitive magma It gives an idea of the composition of mantle which gave rise to the melt. So, it's very important, or its understanding is very significant, because with this knowledge we come to know about the evolution of magma. Primitive magma has undergone minimal differentiation. Now, parental magma. Parental magma or parental melt, it refers to the magma from which the observed range of magma has been derived by the process of magmatic differentiation. And parental magma is capable of producing all types of rocks belonging to igneous rock series by the process of differentiation. So, it is important in understanding the evolution of magma. Parental magma is derived from primary magma directly through melting of deep-seated primary magma. Now, let us come to the physical properties of magma. The crystallization of magma, it is governed by following factors: temperature, viscosity, density, presence of volatiles or gases. Temperature. It's very difficult to measure the temperature directly because it involves a lot of danger. But scientists have measured directly the temperature of 1200 degrees centigrade in the flowing lava, which is possible only by remote control. The laboratory measurements and field observations indicate that magma crystallizes between the temperatures ranging from 1200 degrees centigrade to 650 degrees centigrade. The temperature of magmas, they indicate the eruption temperature. Like basaltic magma, it crystallizes between 1000 degree to 1200 degrees centigrade. Andesitic magma, it crystallizes between 800 degrees to 1000 degrees centigrade temperature, whereas rhyolitic magma, it crystallizes between 800 to 650 degrees centigrade. The term viscosity is quantified as the resistance offered to the flow of magma. Thus, it controls the mobility of the magma. Viscosity, primarily it depends on the composition and temperature of the magma. Volatiles, as you know, they impart low viscosity to the magma. Thus, viscosity is an important property that determines the eruptive behavior of magma. Felsic magma, in other words, the magma comprising more percentage of silica oxide, they are more viscous as compared to the mafic magma, which comprise less percentage of silica oxide. Cooler magmas are more viscous than hotter magmas of the same composition. Now, why do you think felsic magma, as I told you in the previous slide, they have low viscosity? Because they have higher silica oxide percentage, and magma has higher viscosity as compared to mafic magma. Felsic magmas, because they have got a very complex crystal system with increasing silica composition, and this tends to offer them higher viscosity, and temperature also controls viscosity of the magma. Presence of more volatiles in felsic magma result in explosive volcanism as compared to mafic magma. Now, density. The density of magma is 2.65 grams per centimeter cube, and that of mantle is 3.3 grams per centimeter cube. Composition, temperature and pressure are important factors in controlling the density. More iron rich magmas are more denser. You understand? because the basaltic magmas are higher in iron, calcium, titanium. So they have got higher density that ranges between 2.65 to 2.80 grams per centimeter cube. Rhyolitic magmas, they have more sodium, aluminum, silica, so their density is less. That ranges between 2.18 to 2.25 grams per centimeter cube. So the density of andesitic magma, it ranges between somewhere between a basaltic and rhyolitic magma, that is between 2.45 to 2.50 grams per centimeter cube. So the increase in temperature causes lowering of density. On the contrary, higher pressure increases the density of the magma. Volatile gases. Around 90% of volatiles and gases are present in magma. As the pressure decreases, magma rises towards the surface and forms a separate vapor phase. Let me give you one example. Like when you open a cold drink bottle, I can say, in other words, the gas in the magma is similar to carbonated beverages bottled at higher pressure. As soon as the cork is opened, the pressure lowers and carbon dioxide dissolved in the beverage, it is released. Okay? So I hope you understand this concept. So the volatiles, they provide explosive character to the magma because of the volume of gas expands as the pressure is released. Basaltic magma, therefore they are known as dry magmas because they have low volatiles, and H2O that is less than 5%, whereas felsic magmas or felsic rocks like granite and rhyolite, they consist of high H2O content that ranges between 0.5% to 0.7%. You see on your screens on top left, sulfur dioxide that is escaping, and it is by the process of sublimation, it is forming yellow deposit comprising of sulfur deposits. And you see a pie chart which shows you the average percentage of different volatiles that comprise a magma. Now let us talk about the composition of the magma. Based on extensive petrographic data, it is established that magma comprises of diverse mineralogical composition, and you get diverse textures, and this diverse mineralogy and diverse texture, it is the result of difference in the composition of the magma and the conditions of cooling. Magma is essentially silicate in composition, and its crystallization, it begins at a higher temperature levels, and in the range of crystallization the temperature decreases and it gives rise to different kinds of rocks. Components of magma, as I told you earlier, magma, it consists of three states. Liquid magma, it consists of a mixture of materials in all three states: liquid, solid and gas. Liquid portion is the belt, which consists mainly of mobile ions of 8 most common elements found on the earth: oxygen, silica, aluminum, iron, calcium, sodium, potassium, magnesium. Solid, it includes silicate minerals that have already crystallized from the melt, and gaseous component, it comprises of volatiles like water vapors, carbon dioxide, sulfur dioxide and other minor constituents like HCl, H2S, HF, nitrogen, chlorine, fluorine and bromine. Let us talk about the chemical composition of magma. Magma do not have any fixed chemical composition. Petrologists, they have described the chemical composition of magma in terms of weight percentage of various major oxides. Now you can see on your screens there is a table. Basically, the magma, it is made of 10 elements that include silica, titanium, aluminum, iron, magnesium, calcium, sodium, potassium, hydrogen, oxygen. These together, they constitute more than 99%. You can see on your screens the oxides that dominate the composition of the magma are silica oxide, aluminum oxide and iron oxide, or it can be calcium oxide. Chemical composition of the magma, let us continue with the discussion. As I told you, on average silica percentage is about 59%. It is followed by aluminum percent, which is 15%, and this forms the major component of any magma. All the magmas that contain silicon and oxygen, and this silicon oxygen, they bond and they form silicon oxygen tetrahedra. On your screens you can see the tetrahedra. So as the complexity of the tetrahedra increases in the magma, or you can say in felsic magma, the complexity of the oxygen, or you can say in other words, in felsic rocks, the complexity of silicon oxygen tetrahedra, it increases, and with the increasing of the complexity, the magma becomes viscous. So silica oxygen tetrahedra is the fundamental component of most silicates on the Earth's crust. So the silicon oxygen tetrahedra is the fundamental component of most silicates found on the Earth's crust. Now this is mineralogical composition. The felsic rocks, which include light silicates, the minerals are quartz, muscovite, mica, feldspar group minerals, which are richer in silica. And you know, feldspars, they make about 40% of most igneous rocks. Basically, the minerals in felsic rocks are quartz, orthoclase, feldspar, plagioclase, muscovite, and the mafic rocks. They basically comprise dominantly of the minerals like olivine, pyroxene group minerals, amphibole group minerals, and biotite, that is mica group mineral. Pyroxene group minerals can include clinopyroxene, orthopyroxene like augite, hypersthene. Now, major types of magma. Earlier petrologists thought that there are 4 different types of magma: felsic magma, mafic magma, intermediate magma, and ultramafic. But now it is widely accepted that there is a single parental magma which is homogeneous and it is basaltic in composition. N.L. Bowen in 1923, he established the concept of primary magma. Now this primary magma that can produce parental magma or secondary magma. So Bowen advocated that different varieties of igneous rock have been originated from single parental magma by the process of magmatic diversification and differentiation. Now here you see the chemical and physical properties of different magma types. Felsic, that is rhyolitic, and its composition, it ranges between 65 to 75% with low iron, magnesium, calcium and high potassium and sodium. Temperature is 650 to 800, viscosity and volatile contents are high. Intermediate, that is andesitic, silica ranges between 55 to 65% and It has intermediate iron, magnesium, calcium, sodium and potassium. Temperature ranges between 800 to 1000 degrees centigrade, and viscosity and volatile content is intermediate. Mafic, it is basaltic. Silica ranges between 45 to 55%. It has high iron, magnesium, calcium and low potassium and sodium, and temperature ranges between 1000 to 1200 degrees centigrade. It has low viscosity and low volatile content. And ultramafic, or you can say picritic, the silica content is ranging between 38 to 45%, and it is very high iron and magnesium more than 8%, up to 32% magnesium and low potassium and sodium, and its temperature is up to 1500 degrees centigrade, and viscosity is very low, and volatile content is also low. So, in earlier slide we discussed that geologists distinguish 4 different types of magma on the basis of silica, that is silica SiO2 percentage, and different types of rocks are formed due to differentiation of magma. Now, let us define what is magmatic differentiation. Magmatic differentiation is the process by which magma is able to diversify or differentiate and produce different rocks of different composition. Let us discuss origin of magma. So, the petrologists, based on their knowledge that have been generated, they confidently say that overall compositional range and systematic variation in composition of natural magma is primarily the result of 2 important processes that take place within the earth. These 2 processes are partial melting and fractional crystallization. So, what is partial melting and fractional crystallization? Partial melting, it controls the composition of initial magma when it is formed deep within the earth, and fractional crystallization is the process that changes the composition of the magma as it makes way towards the surface of the earth. Or in other words, you can say that magmas originated through the upper mantle, they undergo partial melting under such physical condition. Some magmas also result from the melting of rocks in the lower regions of the continental crust. Why do mantle or lower crustal rocks melt? See, earth is not covered everywhere with volcanoes. There are regions in earth in which melting is caused by various processes. So, the following 3 processes, either alone or in composition, they cause the upper mantle or lower continental crustal rocks to melt: increase in temperature, decrease in pressure, and addition of fluids dominated by water. Now learners, let us summarize what we have discussed in this video. Magma is the melt beneath the surface of the earth, and lava is the melt that emerges on the surface of the earth. Magma consists of complex mixtures of solids, fluids and volatiles and dissolved gases. Crystallization of the magma is governed by temperature, viscosity, density, volatile and gases. 10 elements constitute more than 99% of magma. The common mafic minerals, they are olivine, pyroxene, amphibole and biotite. Common felsic minerals are quartz, muscovites and feldspar. Magma can be grouped into felsic, mafic, intermediate, ultramafic based on silica percentage. Process of magmatic differentiation is responsible for the diversification of the magma. Thank you.